Okay, guys, welcome back to Mr. Morrow's Algebra 1 class. Today we're going to continue in Chapter 2, and we're going to be solving two-step equations. Okay? Yesterday we learned how to solve one-step equations. Today we're going to be talking about how to solve two-step equations. Just like yesterday, what is the goal, do you think, of any single equation? One step, two steps, or a million steps? Get the variable by itself. Isolate the variable, yes. And when we isolate the variable, we want to solve the variable in what form? What does the variable got to look like? X over 1. Remember, when you're solving for the variable must be alone, positive, and in the numerator. If it's not positive, you haven't completely solved it yet. If it's not alone, you haven't completely solved it yet. If it's not in the numerator, you haven't completely solved it yet. Okay? Now, I just put x, that's a popular variable. It could be y, p, g, w, x, k, it doesn't matter. Whatever variable you're solving for must be isolated alone. It must be positive and in the numerator. Now, there are two steps and only two steps for solving two-step equations, hence the two steps. And the beauty of it is it's the exact opposite or the reverse of the order of operations. What are the last steps of the order of operations? Add and subtract in order from left to right. Very good. So in this particular case, we're going to reverse that. So we're going to get rid of or undo addition and subtraction first. After we have gotten rid of addition and subtraction, we're going to go ahead and undo multiplication and or division second. And literally, those are the notes. That's it. That's all there is to this. Those are the notes. We're going to do a bunch of examples now, of course, but those are the notes. One thing I will add for everybody's benefit, please remember the following, okay? Let me just type this up since I thought about it. It's only fair. Let me explain it just to make sure. Okay, so we have what's called equality properties, okay? And please remember that the equality properties come from using inverses. Okay, sorry about that. So when we're using the equality properties, it's coming from the inverses. Remember, we learned the additive inverse and the multiplicative inverse. Remember that the additive inverse is whenever you add the opposite of a number to a number, the answer is 0. So for example, what is the additive inverse to positive 5? Negative 5. What is the additive inverse of negative 5? Positive 5. Multiplicative inverse. What's the multiplicative inverse of 7? 1 over 7. It's the reciprocal. What is the multiplicative inverse of 1 over 7? 7 over 1. Excellent. So the equality properties coming from the inverse properties, you have the addition property of equality. Okay? That means that whenever I add the same number to both sides, I was allowed to do that because of the addition property of equality. If I subtract the same number to both sides, I just use the subtraction property of equality. Okay? If I multiply the same number to both sides, I just use the multiplication property of equality. And if I divided something to both sides, I did that because I used the division property of equality. Does that make sense, boys? Okay, and all of these, like I said, come from the additive or multiplicative inverses. Please remember that vocabulary is very important. Okay, so you must know this. They may say to you sometimes, solve and justify each step. Solve and justify each step. Okay, so let me show you what that means in the next example. Not only are we going to solve, but the first one only I'm going to solve and justify each step so you can know what I'm talking about, gentlemen. Okay, for example, I got 3n minus 4 equals 11. Hold on for 1 second. The questions I'm always going to ask myself is, okay, I got to get rid of addition and subtraction first. So 3n minus 4. Okay, I have a negative 4 here that's being added to the 3n. How do I get rid of a negative 4? By using the additive inverse, so I add 4 to both sides. What property of equality allowed me to add 4 to both sides? The addition property of equality. Then I'm left with 3n equals 15. How do I cancel 3 times n? 3n is multiplication. How do I cancel multiplication? Division. So I'm going to divide by 3 to both sides. What property allow me to divide the same number to both sides? The division property of equality. And then n will equal 5 because 15 divided by 3 is 5. And that's closure. Okay, if you remember that, that's just that a real number divided by a real number is a real number. Okay, so if they ever say justify your steps, that's what this means. If they say justify each step, that's what I'm talking about. Justify each step, it's right there. Okay? So now, I don't have to justify all of these, but I do want to go over them and make sure we solve them correctly, all right? Because these are two-step equations. Okay, I have y divided by 5 plus 2 equals negative 8. Talk to me, somebody. Yes, sir. You're going to undo addition and subtraction first, so what are we going to get rid of? The positive 2. How do we get rid of that positive 2, my man? Absolutely right. You subtract 2 to both sides. Always go from left to right. What are we left with on the left side? Yes, that cancels, so we go y over 5. Always go left to right. What's negative 8 minus 2? When the signs are the same, you add and keep the sign. How do I get rid of that 5 that's being divided to y? Yes, sir. Keep going. You multiply by the reciprocal. That is absolutely fantastic, son. I couldn't have said it better myself. So y equals negative 50. Talk to me. That isn't so hard, is it, guys? Now, if you don't follow my directions, is it going to get tough? Yes. If you do it the way you feel like doing it without following directions, is it going to get tough? Yes. If you don't follow the rules, it's going to be very difficult. If you follow the rules, it's going to be very simple. Okay, I got negative 14 equals negative 5 plus 3c. Talk to me. What do I do first? Yes, sir. You're going to get rid of this negative 5, so you're going to add 5 to both sides by using the additive inverse and the addition property of equality. What do I got left now? Left to right. Negative 9 equals 3c. You okay, bud? Bless you. I was coughing. Next. The relationship between 3 and c is multiplication, so I'm going to divide 3 to both sides. So c equals negative 3. A negative divided by a positive is a negative. Okay. Yes, sir. Yeah, okay. It says negative 5 plus 3c. What's being added to the 3c? A negative 5. How do I get rid of that negative 5? By adding 5. Thank you. Great question, son. Good man. Now, for number 4, do not write this down for a second. Please. Pay attention. Please. 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 Just put it down. Put your head. I don't want you to erase anything. Just pay attention. Please. This is the way most people teach it. This is the way most of you would probably attack this right now. I'm going to show you what most of you would do, and I'm going to show you a better way, which we went over yesterday, but I'm going to repeat it again today without a problem. Most people would start like this. They'd add 1/3 to both sides. You got 2/5 x equals. Common denominator here is 30. So you multiply 3/3 to both sides. That's 9/30. To get to 30, you go 10/10. That's 10/30. So 2/5 x equals 19/30, right? How do I get rid of this 2/5 that's being multiplied to the x? You multiply by the reciprocal, thank you very much, gentlemen, of 5/2. So then x is going to equal, 5 goes into 5 one time, 5 goes into 30 6 times. So I've got 19/12, which equals 1 7/12. There's nothing wrong with that. Absolutely nothing. If you did it like that for every problem, God bless you. Good for you. You probably won't finish the test though. And you're probably going to make some errors because we're all human. There was a lot of steps involved here, okay? And I'm not trying to be mean, but some of us are still not really perfect with fractions. So I have devised a way to eliminate having to use fractions. Now you can write what I'm about to write. Yesterday we said that to get rid of fractions, to get rid of the denominators, we can multiply everything by the... No. We multiply by the reciprocal to isolate a variable. Like let's say that was 2a. I multiply by the reciprocal here. But I'm not getting rid of the denominators, guys. Come on, think about what you just said there. This is going to be 15/32. I still have a denominator. So no, that is not what I said yesterday. To get rid of the denominator. Thank you, sir. I'm so proud of you. Thank you for listening. You multiply by the LCD, the least common denominator. What's the least common denominator here? 30. So check it out. Multiply 30 to both sides. Remember how I promised you you'd be seeing distributive property? You're going to see it right now this second. So this is 30/1. Please be sure to remember it's in the numerator. So 30 times 2x over 5, that's going to be 60/5x, correct? Because 30 times 2 is 60, 1 times 5 is 5, right? And the x is in the middle, so that means it goes to the top. Hello? Okay. 30 times a -1/3. Well, what's -30 times 1? -30. And what's 1 times 3? 3. Boom. Done. Equals 3 times 30 is 90/10. Now it's Mickey Mouse time. 60x divided by 5 is 12x. -30 divided by 3, -10, equals 9. Now I undo addition and subtraction first. Add 10 to both sides. 12x equals 19 divided by 12. X equals 19/12, which equals 1 7/12. In my opinion, that's way better because you don't have to deal with the fractions. Are you allowed to do it the first way I showed you? Yes, 100% you're allowed. If you're really good at fractions and you want to do it like that every single time, God bless you. Good for you. If you're really good at it, you will have enough time. But if you're not good at fractions and you fumble through them, I definitely do not suggest that. I suggest you become a master of finding the LCD. Make sure you know how to distribute so you can properly solve this correctly. Does that make sense so far? All right. Now, come again, son? Okay, the question was, wouldn't the least common denominator be here 15? No, because what times 10 gives you 15, son? What times 10 gives you 15? Nothing. So 15 cannot be the denominator. Thank you, sir. Okay, now here. Let me explain what this is really saying to you. Don't write anything right now, just pay attention, please. Do you guys remember that this is just the reverse of the distributive property, but for division? So what this really says is y/2 minus 4/2 equals 10. You with me? So what this really says is y/2 minus 2 equals 10. Add 2 to both sides. y/2 equals 12. Multiply by the reciprocal. y equals 24. So that makes sense because this 2 is distributed to the y and to the 4. Yes, sir. I can do several different ways. I didn't say this was the only way. I asked if you understood this way. That's what I asked, guys. Does that make sense what I just did there? Gentlemen? Okay. Now, let me show you the shortcut. Because I like to give you shortcuts if it's possible and if it works every single time. You know how we undo addition and subtraction first, correct? Okay. Can I really undo this negative 4 though? If I add 4, does that make sense that I'm getting rid of the 4? No, right? Because I don't really have a y minus 4, right? I have a y minus 4 over 2. So I have to do a division there before I can get rid of the addition, the subtraction. So what I have to do here is release the top. So I got to get rid of this 2 in the denominator. How do I get rid of that 2 in the denominator that's being divided? Multiply by 2, absolutely, to both sides, gentlemen. 2 divided by 2 is 1. So I got y minus 4 equals 20. Add the 4 to both sides. Isn't that a lot easier, guys? No, you don't think that was easier? Okay. So how about for number 6? I got a 5 down there in the denominator. Okay, I want to get rid of that sucker. So I'm going to multiply by the reciprocal of 5 over 1 to both sides. 5 divided by 5 cancels. So I got x plus 3 equals negative 5. Subtract 3 to get rid of the positive 3 to both sides. X equals negative 8. For number 7, how do I get rid of that denominator there? Because that denominator is affecting the d minus 7. So I need to get rid of that denominator. So how do I do that? Multiply by the reciprocal. Very good, son. So you're going to multiply by 7 over 1 to both sides, gentlemen. So 7 times negative 2 is negative 14. And that's going to equal 7 divided by 7 cancels. And I got d minus 7. I add 7 to both sides. D equals negative 7. Okay, now, here. Is this the same format? Can I just multiply by 8 here to begin with? Is that the same format as 7, guys? Think before you speak. Now, could I multiply everything by 8 here? Could I? Yes. Would I? Not in this case. If you wanted to, sure, you can multiply everything by 8. Then you'd have negative 8 equals 32 plus 5x if you wanted to get rid of the denominator. Because I just showed you over here on this one, remember if I want to get rid of the denominator, I multiply by the LCD, correct? The denominator of the 5x is an 8. The denominator of 4 is 1. The denominator of negative 1 is 1. So what's the common denominator? 8. So if you don't want to work with fractions ever, you can multiply by the LCD always to begin with. But in this particular case, I probably would not have done that. Okay? Me, personally, if you wanted to, you can. You're going to get the same answer. But what I would have done, me personally, is subtract 4 to both sides. Got negative 5 equals 5/8 x. Multiply by the reciprocal. Multiply by the reciprocal. Right? So 5 goes into 5 one time. 5 goes into negative 5, negative 1 times. Negative 8 equals x. It's a lot easier, in my opinion. Does that make sense, everybody? Promise. Okay, you know we're going to have a quiz on this tomorrow, right? And a test on the first 3 sections. Actually, yeah, next week sometime. Yes, sir. I don't know. Questions on this? Yes. I'm not done doing examples. Yes. Give me 1 second, buddy. Thank you, my man. Thank you, Eder. Does that make sense, gentlemen? Okay. Now, I was requested. Hold on. I got more practice set up for you, but how about if I have this, bro? Let's say 2/3 x plus 1/4 equals, I don't know, 5/6. All right, nobody wants to work with fractions, so we want to get rid of the denominators. So what do? Okay, you first find the LCD. The LCD here is 24. Actually, no, not 24. 12. Could I use 24? Yeah, you just have bigger numbers. That's all. So I multiply 12 to both sides. I'm going to distribute. 12 times 2 is 24x over 3, because 1 times 3 is 3. Distribute. 12 times 1 is, and 1 times 4 is, and that equals 5 times 12 is over 6. 24x divided by 3 is 8x. 12 divided by 4 is 60 divided by 6 is, now what do? Now it's easy. Subtract 3, you undo addition, subtraction first. Okay, then I got 8x equals 7 divided by 8 to both sides to cancel out multiplication. X equals 7/8. That makes sense, boys? Does that make sense? You promise? Because I'm going to erase it now in a second. Ask if you're going to ask. Okay. Yes, sir. We do not have to do reciprocals here. Reciprocate, yeah. Yes, then it goes to the denominator, yeah. Absolutely. Thank you, son. The question was, if I have, like, let's say negative 3/5 x equals, whatever, 10. I'm going to multiply by the reciprocal. So, yeah, it's going to be 5 over negative 3. But regardless, what's a negative divided by a positive? Negative. What's a positive divided by a negative? So does it really matter where it goes? No. Just as long as it's there. See what I'm saying, Bubble? Thank you, sir. All right. Now, I'm going to take us to a website. We don't have that many minutes to work on this, but the website's going to be up. This is on video. So you are allowed to go to that website, hey, and continue on your own if you so want to do better. Okay. Number 1, I got 6 equals a over 4 plus 2. What do? Subtract 2 to both sides. Absolutely. That's going to be 4 equals a over 4. How do you get rid of the 4 that's being divided to the a? You multiply by 4 over 1 to both sides. Multiply by 4 over 1 to both sides. A equals 16. All right. How about number 2 is exactly the same as number 1. Different numbers, though. How about number 3? What do I do here? Okay, you got nx minus 7 equals negative 7, so I got to get rid of a negative 7 by adding 7 to both sides. 9x equals 0. This is good that this did this. How do I solve for x? Divide by 9. X equals what's 0 divided by 9? 9. 0 divided by 9 is 9? No. 0 divided by 9 is 0, gentlemen. Please be careful. Please be careful. Okay, how about number 6 over here? How about number 6 right here? I've got negative 1 equals 5 plus x over 6. What's the easy way to solve this one? What's the easy way to solve this one? Multiply by 6 over 1. Very good. So I multiply by 6 over 1. What's 6 times negative 1? Negative 6 equals 5 plus x. Now I subtract 5 to both sides. Negative 11 equals x. Does that make sense, gentlemen? Okay. We're all good? All right, remember, look, guys, just real quick. Don't let this disturb you. Look at number 8. What do you have to do first here? Distribute. So this is 2n. plus 10 equals negative 2. Then you solve from there. May God bless you. Have a great day. Thank you for a good class. Peace out.